Hello, welcome back to Mr. Kendrick's online math class. This is going to be lesson 5.5, Constant of Proportionality. Now if you have the printed insert, you can take your notes on that. If not, you can turn your notebook to the next blank page and put this lesson title at the top. Alright, let's do a quick review of proportions. Alright, when are relationships proportional? So if we're working in a word problem, we have a proportional relationship. In this situation, Mark is a landscaper who earns $60 for 2 hours and $150 for 5 hours. And if we divide the amount of pay for the amount of hours they worked, you'll find that both times Mark earns $30 per hour of work. So he gets the same pay per hour, as well as if it was on a graph, the graph would go through the point 0, 0 because if he didn't work any hours, he would not make any money. If we're looking at a graph, we have a proportional relationship when we have a straight line, and when the graph also passes through that origin, point 0, 0 on the graph. When we're looking at an equation, we have a proportional relationship when the equation is written in the form of y equals kx, where k is the constant. So in this equation, y equals 30x. It would be a proportional relationship because it is in the form of y equals k times x. And we're going to be working with that today. When we look at a table, if we have a table, we know we have a proportional relationship when each ordered pair can be simplified to the same ratio. So if we divide the pay by the hours worked, both 2 hours to $60 and 4 hours to $120, we get paid $30 per hour. So each ordered pair simplifies to the same ratio. Okay, the first thing that I want you to write down in your notes today is the constant of proportionality. The constant ratio in a proportional relationship is known as the constant of proportionality. And we've been working with this in our last lesson. We just called it something different, and we called it the unit rate. So the constant of proportionality is the same thing as the unit rate. Make sure you get this written down before you move on. Alright, the second thing, the constant of proportionality is the y value that corresponds to the x value when x is equal to 1. So if we look at a table or a graph and we have a value for x when x is 1, the y value that corresponds to that x value would be the constant of proportionality. And we can find it by dividing the y value by the x value. So you can pick any ordered pair, and you can divide the y value by the x value to find the constant of proportionality. Okay, so make sure you go ahead and pause here and write this information down in your notes. Make sure you have it copied on your insert. Alright, constant of proportionality from an equation. So you can see here we have 3 different equations. We have y equals negative 3x, y equals 2x, and y equals x. And the lines are plotted on the graph here to the right. And you can see that each one is a straight line. And this tells us right here, all of these points are going through the origin, point 0, 0. So they are all proportional relationships. And then proportional equations will always be written in the form y equals kx. Okay, so if we see an equation that is written in this form, we know that it is proportional. And k just represents a constant. So it's just a number multiplied by the x. Alright, we're going to look at some examples here. I want you just to watch as I go through these. So we're looking to tell whether x and y are proportional. If so, we want to identify the constant of proportionality. Okay, so we're looking for equations that are written in this form, y equals kx, and that'll tell us if it is a proportional relationship or not. So this first one, we have y equals 3/4 times x. This would be a yes, it is a proportional relationship because it's in the form of y equals k times x, and 3/4 or 3/4 equals k. So you'd have 3/4 is equal to k, or that's our constant. B would also be a yes. Now I know that the x and the y are on the opposite side of the equal sign, but that doesn't matter. We can put them in either order, and we can still see that it's y equals k times x, and 7 would be equal to k. Alright, letter C, we have y equals 3x plus 5. This would be a no, it is not proportional, because it is not in the form of y equals kx. This plus 5 here changes our equation and changes our proportional relationship. So this would not be a proportional relationship. Alright, and then the last one, D, we have x minus y equals 0. So because we have no numbers adding or subtracting to in the equation, we can solve for, we can put the y on the other side of the equation by adding y to both sides. If we add y to both sides, we'll cancel here and we'll get x equals y. Now remember, every time we have a variable, there's an invisible number connected to that variable. So we have, this is like y equals 1x. So this would be proportional because once we just do the operation of moving the y to the other side of the equation, we can see that it is actually in the form of y equals kx, where k is equal to 1. Alright, make sure you have these written down before you move on. Alright, now let's look at constant of proportionality from a table. We want to look at these two tables and tell whether x and y are proportional. If so, we want to find the constant of proportionality. Alright, so this first one, we have x and y, or x over y, and we have 3, 6, 9, 12 for the x, and 0, 3, 6, 9 for the y. Now, something that I want you to recognize here is that the x value of 3 and the y value of 0 instantly tell us that this is not proportional. Because if we put this into the graph, it would not pass through the origin at the point 0, 0. When x is 0, y is 0, that is not true for this situation. We can also look at these two, some other ordered pairs. Like let's look at 6 over 3 equals 9 over 6. Now if we have a proportional relationship, these should both equal the same number. So 6 divided by 3 would be 2, and 9 divided by 6 would be 1.5. So this is not proportional. Alright, then if we look at the other one, we have 4, 6, 8, and 10, and we have for the x and y is 12, 18, 24, and 30. So if we look at these points, we can see that x and y, if we look at 10 and 30, if we reduce to that, dividing by 10, we would get 1/3. 24 and 8, if we divide it by 8, we would also get 1/3. 6 and 18, if we divide it by 6, we get 1/3. 4 divided by 12, if we divide by 4, we get 1/3. Okay, and if the table continued to go, we would end up at 0, 0. So this is proportional. And it's proportional because each one of these ordered pairs can reduce to the same ratio. Alright, constant of proportionality from ordered pairs. So it tells us that x and y are proportional, and we want to use the ordered pair to find the constant of proportionality. Alright, remember that the constant of proportionality is found, or k is equal to y divided by x. So remember, in these ordered pairs, we always have the x value, and then we have the y value. So we have x, y, x, y, x, and y. And we're going to divide the y value by the x value. Okay, so first one here, to find the constant of proportionality, we're going to divide 24 divided by 4. Alright, so when we divide here, we're going to divide 24 divided by 4. So 24 divided by 4, and that is equal to 6. So k equals 6 for that first one. Next one, we got 27 divided by 3. And we know that 27 divided by 3 is 9. So k is equal to 9 here. And the last one, we're taking y divided by x. So 15 divided by 2. And 15 divided by 2 will be 7.5. So k is equal to 7.5. Okay, so when we have an ordered pair, we're always going to divide the y value by the k value, and when we have an ordered pair, the x value always comes first. X, y. Alright, now looking at constant of proportionality from a graph. And remember that the constant of proportionality is the y value that corresponds to x when x is equal to 1. So the graph is proportional because it is a straight line and passes through the origin. So the graph is proportional because it's a straight line and it passes through the origin, 0.00. Find the constant of proportionality. Okay, now a lot of times when we're looking at a graph, we can look at the graph and we can say, well, remember x is on the going horizontally and y is going vertically. So these are the x values here. X, y. So the constant of proportionality is when x is equal to 1. Okay, so we can look at that and say, well, x is equal to 1 here, and y looks like it's about 30. Okay, so I'm going to say k is equal to 30. And then we can also find that by picking an ordered pair and then dividing the y value by the k value, or by the x value. Okay, so I'm going to pick this point here just to check. And we got x is 3 and y is 90. So we're going to divide 90 divided by 3, or y divided by x, and that is going to be equal to 30. So k is equal to 30. C says, interpret the constant of proportionality. So what does the constant of proportionality mean? It means that whoever this person is that's working, they are making $30 per hour worked. Okay, so that's what the constant of proportionality tells us. Alright, and then D, it says, how much money would you earn if you worked 8 hours? Alright, so the first thing I'm going to do is I'm going to write an equation. Okay, and I'm going to write an equation by using the points in the graph. And remember, our equation needs to be written in the form y equals k times x. Okay, and we just found the unit rate, or the constant of proportionality, which is $30 per hour. So we can say that the equation would be y is equal to $30 times the number of hours worked. Okay, so for example, $30 times 1 hour would be y would equal 30. $30 times 2 hours, y would equal 60, and so on. Okay, so our equation is y equals 30x, 30x. And now the last one says, how much money would you earn if you worked 8 hours? So we can do this, but we can figure this out by plugging 8 in for the value of x. So y equals 30 times 8. And then now we can solve. We get 30 times 8, and that's going to be 240. So when x is 8, y would equal 240. So he would earn $240 if this person worked 8 hours. Alright, last one here. Constant of proportionality with the unit rate and word problems. So we have Sam bought 17 apples for $4.25 and Pam bought 10 apples for $2.50. Did they pay the same amount for each apple? So we want to figure out how much one apple costs for each of these people. So for example, the first thing we're going to do is we're going to divide the total amount paid by the number of apples. So for Sam is going to be $4.25 divided by 17 apples, and Pam will be $2.50 divided by 10 apples. Okay, so if we pull up our calculator here, we'll do 4.25 divided by 17 apples equals 25 cents. So K is equal to 0.25, so 25 cents per apple. Okay, and then if we look at Pam bought 10 apples for $2.50. So if we divide 250 by 10, we'll get 2.50 divided by 10, and we get 0.25. So K equals 0.25, so 25 cents per apple. So yes, they did pay the same amount for each apple.